Welcome to class. In today's class in physics, we are going to be looking at Lami's theorem. Lami's theorem states that if three coplanar forces acting at a point are in equilibrium, then each force is proportional to the sine of the angle between the lines of the actions of the other two forces. This is Lami's theorem. If three coplanar forces acting at a point are in equilibrium, then each force is proportional to the sine of the angle between the lines of the action of the other two forces. We are going to be investigating this theorem with a very quick sketch. Before we go into this sketch, I wonder why some of you love what you're seeing in my videos and then you don't like, you don't subscribe, and you don't share. If you are among those set of persons, make sure you subscribe, make sure you like, make sure you share. Let's continue. In Lami's theorem, which I have just stated, that for three coplanar forces like this, coplanar forces are forces that are acting on the same plane and acting at a point are in equilibrium. If these three forces are in equilibrium, so this is F1, this is F2, and this is F3. The angle of inclination between F1 and F2 is theta. Angle of inclination between F2 and F3 is beta. Angle of inclination between F3 and F1 is gamma. Lami's theorem says that each of these forces is directly proportional to the sine of the angle between the lines of action between the other two forces. So F1 is proportional to sine beta. So for F1, the angle between the lines of the action of the other two forces is F2 and F3. So this is the angle. For F2, the angle between the lines of the action of the other two forces, F2 and F3, this is the angle, gamma. For F3, the angle between the lines of the action of the other two forces, F1 and F2, is theta. So Lami's theorem says that F1 directly proportional to sine beta, F2 directly proportional to sine gamma, and F3 directly proportional to sine theta. From there, we are going to do some analysis in each of these cases. If I remove the proportionality sign, F1 equals to K sine beta, divide both sides by sine beta. What I now have there is that sine beta comes to sine beta. I have just K left. F1 all over sine beta is equals to K. I'm going to do the same thing here. Divide both sides. Remove the proportionality sign. I have K sine gamma. If I quickly divide both sides by sine gamma, I didn't include it because that's the same thing we did here. So divide both sides by sine gamma, divide both sides by sine gamma. All right. I'm writing that faithfully. That's deliberate because you know what should there. So that is how we eliminated sine gamma, and we have those k left here. And then here we have sine gamma. So we have left F2 over sine gamma equals to K. And we are going to apply the same thing, remove the proportionality sign. You have K sine theta, divide both sides by sine theta. You have K equals to F3 sine theta. So we have been able to find the constant K in each of these parts of Lami's theorem. Having done that, we are going to, because this is the value of K, this is the value of K, this is the value of K. Putting all those three cases together, we now have that K equals to F1 all over sine beta, which is what we had here, all right, equals to F2 all over sine gamma, and the same K equals to F3 all over sine theta. This is Lami's theorem. You can see how simple Lami's theorem is. All right. In the question you're seeing before you on the board right now is from JAM 2024. the very first question. This question is extracted based on the type. So there are some question types that the first question, which is number 1, may not be this question. So from the type which this was extracted, question number 1 had to do with Lami's theorem. So the first question says, from the diagram below, a weight W equals to 60 Newton is suspended horizontally by a string attached to a wall. Find the tension T on the string. This is the diagram represented for you, given to you, okay, to find the tension T. Now, if you look at this critically, you will discover that the weight, this looks like a block here, this weight, according to gravity, is going to be acting downwards, and it's acting, the weight is 60 Newton. And there is an horizontal force acting on that same block in the horizontal direction. And I am having a tension if a string was attached to the wall at that angle which you are seeing. Yes, this angle may be a little bit tricky just to confuse you, but you shouldn't have an issue with that. What we are concerned is this block. If you look critically, you will see that there are 3 forces acting at this point. These are 3 coplanar forces acting at a point in equilibrium. F is F, this is W, and this is T in that direction. So from there, we are going to begin our analysis. Let's move. So from here, we would have it that as a sketch, that we have a tension T acting at a point. And from that point, we have a force F acting horizontally. And this, we have an extension here too, and this angle is giving us 60 degrees, as you can see here. And also we have a weight acting vertically downwards, still from this same point, and that weight is given as 60 Newton. From there, we have just been able to sketch that. Having sketched that successfully, we'll apply Lami's theorem. You can see that these are 3 coplanar forces in equilibrium. If you look at this straight line, right? I need to use this angle 60 degrees to find this angle. So angle on a straight line, 60 plus what will give me 180. Of course, 60 plus x will give me 180. So x is 180 minus 60. So x is 120 degrees. That means this angle is 120 degrees. It is important we find that angle so that we will be able to find T. Moving from there, we will apply Lami's theorem. According to Lami's theorem, we'll start with T. We'll say that T all over the sine of the angle between the lines of the other of the action of the other 2 forces. So the angle between this and this angle, if you look critically, this is the right angle. Yes, this is the right angle. Yes, because this was acting vertically. So I have a right angle there. So everything in here is the right angle. That's 90 degrees. So all over sine 90 equals to the next force. The next is F all over sine. Well, I don't know what this angle is. Assuming I don't know what that angle is, all right, I can move, okay, but I can still find it anyways if I wanted to, because if I extend this line, this is 120, and this is 60, and this is 90. So 60 plus 90 is what? All over 150. I just hope you've gotten what I just did there right now. I extended this. This is another straight line, 120, 60. Of course, this is a right angle. Having done that, we now say that the whole of this is 150 degrees. From there, I would now say that this is equals to the next is this force. This force is 60 Newton. That was our weight all over. You can just guess what that will be. That will be sine 120 degrees. Sine 120 degrees. All right. Moving from there, we will now decide, are we going to compare this with this? Are we going to compare this with this? Or are we going to compare this with this? Remember the aim of this question, we want to find the tension T. Of course, I'm very sure you saw the options that was presented before you. Moving from there, we can say and have it that it will not be wise comparing this with this, because I don't know what F is and I don't know what T is. T is what I'm looking for. That's the tension. It will not also be wise comparing this with this. I don't know what, okay, I can find what F is, all right, but that was not what I was required to find. You can decide to find F first and then use F to find what? T. All right. So comparing this with this is only if I know what F is. A student can decide to compare this with this, find F, and then compare this with this. But because these are objective exams, you have to look for the quickest way possible. When I say quickest way possible, I'm not talking about the shortcut that will hook you in your name and then you get frustrated. No, that's not what I mean. The wise student will quickly discover that we can compare the first and the last. So comparing this with this, that will be T all over sine 90 all over 60 all over sine 120. Quickly, T all over sine 90 is 1. It's a special angle equals to 60 all over sine 120 is root 3 all over 2. We proceed. From there, we can say that T all over 1 equals to 60 divided by root 3 over 2. T over 1 is the same thing as T. That's my tension. Equals to 60 times 2 over root 3. This becomes 120 all over root 3. So T is 120 over root 3. This will be your tension. But the little problem we have there is that the options we have is not represented in that form. So we are going to rationalize the denominator. By rationalization, this becomes 120. Therefore, T equals 120 all over root 3 times root 3 all over root 3. I'm multiplying the numerator and denominator by root 3 so I can rationalize the denominator. Rationalizing the denominator will end up removing the square root sign from the denominator. So this will give me 120 root 3 all over root 3 times root 3 is 3. So 3 goes here 1, 3 goes into 120, 40. So I have 40 root 3. So you can see that we have arrived at an answer. So our answer is C. So you can see how cheap, how simple that question is. And you can, at this point, like, share, subscribe. Don't forget. I am going to show you a method 2 of solving this same question. And we will still arrive at 40 root 3. And this will lead me to what I call the principle of triangle of forces. I will quickly look at that principle and then we'll use that principle to solve this question. So, the same question using the principle of triangle of forces. Using the principle of triangle of forces, we can see that we are representing that diagram by these lines of forces. What does the principle of triangle of forces state? The principle of triangle of forces states that if three coplanar forces act on a body in such a way that the system is in equilibrium, the forces can be represented in magnitude and direction by the sides of a triangle taken together or taken in order. What do we mean by that? If you look at this, I have three forces. So I have, this is my 60 Newton. The magnitude of this force T is the same as this force. So this is T in extension because it's in equilibrium. This T is like the resultant of F at 60 Newton can be taken in that direction. So I can say this is my T and then my F is acting in this direction. This is my F. So you can see that we have a triangle. And if you look at this critically, you will notice that this is 60 degrees. You notice that this magnitude is, of course, 60 Newton. This is my F, and then I'm to find T. If this confuses you, we can also look at this triangle of forces in this other form. We can say that this is my tension, this is my force. If we trace this force down and we do this, you notice something. You notice that, let me do that a bit more perfectly. You notice that this is 60 degrees, that if this line and this line are parallel, then this angle is also 60 degrees. These are alternate angles. This is 90 degrees, and this is 60 Newton because it's in that direction. So you can see that. We can also look at triangular forces in that perspective. So from there, this is theta, this is 60 Newton. Remember, I'm looking for tension. So what connects 60 degrees, which is theta, to 60 Newton and this tension? So we'll say that sine 60 rather, would give me opposite over hypotenuse. What is my opposite? My opposite is 60. What's my hypotenuse? Tension. So sine 60 equals to 60 all over t. So this now gives me sine 60 is root 3 all over 2 equals to 60 all over tension. I cross multiply from there. When I cross multiply, I have t root 3 equals to 2 times 60 is 120. To find t, I'll divide both sides by root 3. Dividing both sides by root 3, I will then have that root 3 cancels root 3. such that t equals to 120 all over root 3. So I rationalize t equals to 120 all over root 3 times root 3 all over root 3. This is 120 root 3 all over root 3 times 3 is 3. So t equals to 40 root 3. So you can see either by using Lami'S theorem, our answer is C, or using triangle of forces, our answer is still C. So this is how we can solve this question simply using Lami'S theorem and triangle of forces. Thank you so much for watching this video. Thank you so much for staying till the end of this class. I urge you, share. If this is the first time you're watching this video, this is the first time and the best time you should share. Thank you. See you in my next class.